So you start, Vianney. Okay. You introduce yourself and what you do, please. And the slides, I'm asking the slides to be put on. I think we have all slides, I hope. Okay, yes?
Okay, so good morning, everyone. So my name is Vianney Taquet. I'm a data scientist working at Confiance.ai, a French consulting company in Paris specialized in data science and artificial intelligence. And so today I'm here to present you MAPI, an open source Python package for estimating uncertainties associated with the prediction of machine learning models. So as you know, estimating uncertainties from ML models is of crucial importance. So it can allow data scientists and engineers to assess the limits of models in productions in industry, and it can also of valuable importance for decision makers in business units, for instance. So, but to our knowledge, we didn't find any robust package, at least in Python, allowing you to easily estimate uncertainties for machine learning models in regression and classification. So we decided to develop this package on a twofold objective. As the name implies, the first objective is to have a model-agnostic estimator that can be plugged to any machine learning model for regression and classification settings. The only constraint is to have a scikit-learn-compatible model. And the second objective is to implement state-of-the-art uncertainty quantification algorithm that give you mathematical guarantees on the marginal coverage, either for regression or classification. So we developed this package with standard open source specification. Basically, it's published on GitHub, documented on Renumix. We also packaged it on PyPy and Conda, and it's now part of scikit-learn-contrib ecosystem. So it's fully compatible with scikit-learn, and if you want to know more, so please feel free to stop by to see our poster. Thank you.
Thank you. Amoku, please come. I was told that you have to use the standing microphone there.
Hello, everyone. Okay. My name is Salum. I'm a PhD student at Stellantis. I will present a joint work with Nicolas Brunel from Confiance.ai. So I'm going to talk about explanation tools, local explanation methods. Today there are many explanation methods that try to explain the local behavior of machine learning system. One of the most popular are feature attribution based, for example with SHAP or LIME. Also, this method gives some insight about the local behavior of the model. They have many issues, which make them less reliable. For example, they are very sensitive to perturbation. They are poor to detect local behavior of machine learning system, and their additive nature or linearity assumption make them prevent them to explain interaction and more complex effects. On the other side, there exist other methods that are less popular but more reliable, which are rule-based explanation and sufficient explanation. In one word, the idea of sufficient explanation is to find the minimal subset of variables that maintain your prediction with a high probability. However, these methods are not currently available in a realistic case. For example, they are only available in classification problem of binary features and require strong knowledge about the distribution of the features. For that, our work, the main goal of our work is to provide a method that overcomes this limitation. For that, we extend the idea of sufficient explanation in regression setting. For that, we find a way to compute this explanation for any distribution, and we prove the consistency of the algorithm. And we also, based on this explanation, provide a rule-based explanation for regression and classification problems. Thank you.
Thank you.
Stefan Suwlak. I'm CEO and founder of Renumix. We're a small startup out of Karlsruhe in Germany, and I'm really enjoying being here today. Maybe you can put on the slide one more because yeah, perfect. And we built ML-powered tools for mechanical engineers. And through our projects, we learned that the main point, the main success factor for these tools is the data-centric collaboration between the domain experts and the data scientists. And I believe that this is also a very good bridge to have a hands-on approach to build trustful AI. What do I mean by this? If somebody tells you, the data scientist tells you, oh, well, I have an accuracy of 95% or an F1 score of 0.9, would you trust the system? Would you use the system? Would it tell you anything? For me, it basically tells you nothing. And at least 3 components are missing in that. First of all, you typically need more information from your model. We heard it in the talks before. You need information about the uncertainty, about the embeddings, about the feature importances. And then you need not only the quantitative results, but we feel, and we see it every day, that you also need the qualitative results. You have to look at the data points in groups and individually. So how do where are actually my errors occurring? What does these errors have in common? And you have to do this in close collaboration between the domain experts, especially in engineering and manufacturing, and the data scientists. And to enable this workflow, we've developed a template. We call it the data curation canvas. It's basically a set of best practices. And we develop software that help to build these data curation cycle and to help build data curation flywheels. And we feel it's a very interesting area. And if you've already built perhaps some data analytics, visual analytics tools or data curation tools, I would really love to learn from your experience. And please meet me at the posters. Thank you.
2 minutes exactly. So now we have number 5, Maxime. Okay.
Okay, so hi, I am Maxime Savary-Leblanc. I am a PhD student at the University of Lille and the CEA list. And today I'm going to talk about fostering trust in software assistance for software engineering. So this morning we were mentioning human aspects of AI systems and imperfect systems. So let me start with a short story. A few weeks ago, we were interviewing 16 software modeling experts who model critical systems. And we were introducing them with software assistants to help them modeling. In fact, this specific software assistant was an artificial intelligence knowledge-based system which provides them with recommendations about modeling. So we were asking a lot of questions, and especially the following: can the system provide bad recommendation, wrong recommendations? And surprisingly, they said, yes, the system should provide bad recommendations. So this was kind of funny, and the justification was even better. They said, we want bad recommendations because bad recommendations is bad from one perspective, one point of view. But from another point of view, maybe it's a good recommendation. So in fact, maybe me, the modeler, is wrong and the system is right. Maybe I just should change my approach, and maybe the system is right and I am wrong. So this says that when it comes to assisting people with intelligent systems, high accuracy is not the key, high performance is not the key, but the system should enable the trust relationship to grow between the user and the system. And this is what we present in this poster. We present an approach which defines what is a software assistant. So it is a system based on a knowledge base, an algorithm, and one or several user interfaces. And we provide preliminary guidelines and directions on how to create this relationship based on 7 criteria for information trustworthiness based on the scientific literature. So
and the rest in front of the poster.
Yeah. Thank you.
Hello everyone, I'm Laurence Guillon. I'm working at Naval Group on predictive maintenance. So we have time series data from raw data from captors. It can be captors of temperature, of pressure, etc. And we have a massive amount of raw data, but most of data is not complete. And the sensor have a bad, sometimes have bad quality, and quality is not monitored for the capture. And it's barely labeled. So sometimes there is label, but we don't know if they are true or not. So we have to do anomaly detection on it, and we did testing different algorithms for anomaly detection of this kind of data. And here are the results of all the algorithms are on the poster. So we can see it.
Thank you. So, Marc, ouais, vas-y. Number 7, Marc.
Hello, everyone. So I'm Marc Naban. I'm a data scientist from Air Liquide, and together with Luca Mostrini from Saint-Exupéry, we're going to present a predictive uncertainty quantification for time series in the scope of Confiance.ai, project number 3, and its application on the Air Liquide use case, which is demand forecasting. So to be quick, the context of the use case, it's we want to predict the future trends of customer demands as precisely as possible. We have a data set comprised of historical consumption, geographical distribution, as well as sensitive customers' information and seasonality data. We have a first solution, an XGBoost that can predict value prediction, as well as a gradient boosting regressor, which can predict intervals prediction. But our objective is to obtain prediction intervals that can have a theoretical guarantee and as well as be the most precise as possible. So we begin by inspecting a first method, first category of method, which is the quanti-regression for prediction intervals. So if, for example, what is a prediction intervals? We have the probability to have a prediction intervals. We define it as 1 minus alpha, where alpha is the miscoverage error. For example, if we want 90% coverage error of coverage, we define alpha as 10%, which is the error. And the quanti-regression can estimate some quantile estimations to have an upper bound and a lower bound together, where we can establish 10% error and maximum in both cases. So now Luca will continue to more talk about the conformalization.
In 20 seconds.
Yeah, definitely. So what we are applying is a conformal prediction, and it's a very simple method to add to wrap around this regressor or classifier with to provide formal guarantees that are model agnostic, distribution free, and non-asymptotic. So if you do mean-based regression, the usual one, you have a point estimate, and you can add error margins that are going to give you a prediction interval that on the long term, on the predictions, on the test predictions, will guarantee that you will have the true y point in the interval. And we can do this with quantile regression. So we have a lower quantile, upper quantile. We can either make it larger or shorter, and then this prediction will be guaranteed on the long term to contain the true data. So in the poster you can see the first application. So we have taken a conformalized quantile regression, which is great. Come see the poster.
Oh, thank you very much. Armin, your turn. Number 8.
Yeah, hi everyone. I'm Armin Dietz from Capgemini Engineering, and we've been working in a project together with a startup called Egg Open on classifying and detecting COVID-19 on ultrasound, lung ultrasound videos. And this poster is a very practical approach to some of the ideas that we already heard in the previous speeches of applying domain adaptation. So we had the problem, actually we started training a model, classifying it, and we had acceptable results. And then at some point we received new data from a different hospital, and every data scientist would say, okay, great, new data, it's a dream, our performance must improve, but actually the performance stagnated or was even worse. So what was happening is when you looked at the data, that there was a very strong bias based from the hospital it was from. And it's very typical in medical data that you have bias everywhere, like from different patients, different physiology, and different experimental setups, different hardware being used, different hardware settings, and you try to mitigate that. So you try to pre-process your data to get rid of that bias. But sometimes it's not possible. Sometimes you don't even know what the bias is. And yeah, so we use domain adaptation to create a model that is independent and to bring all those distributions together. So this is what the poster is about, and I can tell you more about that in detail.
Thank you. Thomas is number 9.
Okay, everybody, I'm Thomas from CA. I work in Action Sheet 6 inside UC5 on data. Also in the fiche there is Fritz and Camille, if you want to talk to them too. So inside our action sheet, we want to answer the question, can active learning be better than random selection of data points for real-world tasks? So active learning is, people have talked about it already, but it's a way to address the problem of data being very expensive to annotate. So it's the idea, can we use the model to pick out a subset of data, which is more important to learn a good model, a good representation. How that works in practice is normally you start with a model, you pick out some initial subset, you train your model on it, you label. You pump through the model the rest of the unlabeled data, and you pick out the most uncertain data points in this unlabeled base. And then you label the most uncertain ones, and you go again in cycles. So in our action sheet, we are addressing object detection problem, specifically traffic road scenes in the BDD dataset with a YOLO V5 model. So the idea is to kind of to detect boxes around objects like cars and pedestrians, etc. So if you want to hear about some first results that we had inside our action sheet, you can come talk to us at the poster. And we can also talk to you about the work that we're planning to do in the next stages of our action sheet. So to do with trying to understand how we can use metadata to improve the process, and also looking at unsupervised machine learning techniques as well, like semi-supervised learning, self-supervised learning as well. So that's it.
Thank you, Thomas.
Hello everyone, I'm Guillaume Mollier. I'm working at CEA as a PhD student, and I will present you, the slide has a problem, no matter.
No.
It's not my
Move
slide.
back, okay.
Okay, thank you. I will present to you the poster about a cross-domain framework for operational design domain specification. So the concept of operational design domain comes from the automotive domain. And it's a tool to represent the specification, the limitation, and the capabilities of a given system. So the idea here is to provide a tool to generalize this concept to any domain related to autonomous system. So we have three important aspects here. The ontology formalization. It's a structured language to represent any concept from a domain. On the taxonomies, it's a little bit your content, so the vocabulary that you will use to represent a concept. So here we will provide some cross-domain concept like weather. For example, it can be adapted for several domains. Every system, as example, working outside. And we provide a third contribution. It's the operational design domain language itself. So it's all the information relevant to represent the capabilities and limitations of the system itself. So it can be exposure probabilities, on the dynamic aspects, the metrics that you can associate to some operating condition, etc., etc. So
2 minutes.
thank you.
Perfect. Perfect. Number 11 is Olivier.
Okay. Can you hear me? Yes. So I'm Olivier Matz, and I'm working at Capgemini Engineering DEMS as AI Program Manager. And today I'm going to talk about speech recognition under constraint. So it's been a long time since my scientific talk, so it's very challenging, only 2 minutes, but it's...
Yeah, you lose time.
So today voice technology are omnipresent in our daily lives, and we can find it in our phones, our computers, and also in our homes. However, while speech recognition technologies are enough mature to be integrated into marketable solutions, they still have some limitation for an adoption in the industry. First, most of them are developed by large group and GAFA, who has access to unlimited access to data and computing resources. Second, they are mainly based on cloud services, which means that you will have to send your data to the cloud. And this can raise issues related to data privacy and GDPR. And this also means that if you don't have access to internet, you cannot use the service. And finally, they are not performing well on industrial conditions, mainly due to the noisy environment or specific business vocabulary, or due to data with a lower sampling rate. So in this context, the question is, how can we develop speech recognition model, efficient model for industry? And in our work, we are taking the challenges of data scarcity and robustness of speech recognition models by developing new cutting-edge methods based on state-of-the-art approaches such as self-supervised learning and data-centric AI approach in order to build speech recognition solution on device. So please feel free to meet me during the poster session if you want to know more about how at Capgemini Engineering we are developing a speech recognition solution.
Thank you, Olivier. Number 12, Aurélien.
So, hello everyone. My name is not Aurélien Benoît-Lévy, but Eiji Kozaki, but he's my co-worker in CA, so I will be presenting his work. So the topic of his work is around randomized smoothing in the special case of Air Liquide dataset. As you all know, deep learning models are susceptible to adversarial attacks. This means that a small perturbation in the input is capable of fooling the model and deep learning models. And randomized smoothing was initially introduced in order to certify the prediction of classifiers. By adding noise in the dataset, it is possible to certify that the classifier output will remain constant within a certain radius around the initial data, unperturbed data. The problem is that in the regression case, of course, if you change the input, you also change the output. So this is a slightly different situation. So during this work, they were able to use a method called percentile smoothing, for which it is possible to certify the prediction of a regression model. So certify that regressor prediction will stay between two bounds, the blue ones that you see in the picture, for, again, data which is slightly perturbed within a radius of the initial data. So please don't hesitate to come visit us during the poster session, and thank you very much.
So we don't, I think that Dumitru is not with us. He wrote to me yesterday evening that he was sick and could not finally attend. So we hope that he will be better. And Cyrielle is our last, number 14. Please. The next one, please. Okay. Yes.
Yeah. So for this poster, we took the subject Confiance.ai quite literally. As robots and intelligent agents are expected to become more and more prevalent in everyday contexts, public reception of robotics and AI is the cornerstone of acceptance, uptake, and research funding of such technology. However, the complexity and the opacity of the systems can have a negative impact on the trustworthiness of this system. So in explainable AI, for example, this shortcoming is addressed by developing a solution that aims at increasing user efficiency, the way that it is used by the design of embodied virtual agents, communicating about the system's results and processes in a natural and a human way. But this impression that the virtual agents, creates can also be a disturbing one and can have also a negative impact on the way we perceive it. So how do we manage the impression that this embodied agent can make? Well, we make first impressions very fast. 50 milliseconds is sufficient to form a first impression of a person that we just meet. And it is spontaneous, and it does not fall into a vacuum. We use a lot of non-verbal signals, such as face, voice, and body, to judge people like we would judge a book by its cover. Well, we can use it to design embodied virtual agents and make sure that they are trusted, that they are perceived as competent, and that the persons feel safe and secure using these systems. So this poster aims at opening a discussion and presenting an approach to the features of embodied AI that elicit emotional response and influence behavior in the human-machine interaction. Thank you.
Well, thank you.